Okay, so talking about functions. So functions in Python, if they are outside of a class, we'll talk about classes and objects maybe a little later on down the road. If they're outside of a class, they're called functions. If they're inside of a class, they're called methods. Basically the same idea. All right, so functions in Python, for example, we can have a function, we use the word def, D-E-F, which is short for define. We say def hello world function, we give it a name, hello world function, and we can take some input parameters if we want to. Okay, now you have to indent, so everything that is indented below the definition of the function is part of the function's body. And we could say print hello world from a function. Notice that this function does not return a value. You might be used to in your math class, you could have a function f of x equals 2x plus 3. So you give it a value for x, you pass in an argument to the input parameter x, it performs a computation and tells you the answer. This is an example of a function that doesn't do anything. Doesn't return an answer, it just performs a task. The task is to print out hello world from a function. Okay, all right, so suppose, for example, we wanted to have a function that calculates the area of a circle. So what is the area of a circle? And the area of a circle is the radius times pi times the radius squared. Pi r squared is the area of a circle, right? So notice in this case, this function actually returns a result. You tell the function the radius, it does a computation and says, here's the area. So for example, we can have, we say, define the function area. It takes in an input parameter, the letter r. It's a tradition in Python, but not required, that your variables start with a capital letter. So r is the first letter of radius, so I'm using capital R. So we have a function defined as area, the name of the function, and it takes in an input parameter of r for the radius. We have a variable called pi, it's equal to 3.14, 14, blah, blah, blah. Okay, and then the area is calculated as pi times r times r. Okay. And then once we know the area, we return the area back to the caller. So if you ask the question like, what's the area of a circle that has a radius of 5, this would calculate pi times 5 times 5. So it would be 25 times pi, which it would be like around 77 or so. So, oh, actually, it's calculated here, 78.5. Okay. So, no, 5 is the argument, the value being passed in. R is called the parameter. So arguments and parameters are two different things. It's the value being passed in. So the argument of 5 is being passed in as the parameter radius. The function calculates the area and returns the value of the area. Okay. So now suppose, this is where it's very important to re-watch the lecture we went over on references to variables, because this is going to cause a lot of confusion. When you call a function in Python, the values are being passed by reference. And so what that means is, suppose we had two numbers, first and last, and we wanted to take those values and swap them. So let's say first is 6 and last is 3, and I would like to swap them. I would like first to become 3 and last to become 6. Well, it'd be nice if we had a function called swap. You give it two values and it swaps their values for you. And then you print them out. Okay, so then the question becomes, would this swap function work? So the swap function takes in two inputs, let's say the left one and the right one. If I say the left one is assigned to a temporary value, the right one is assigned to the left value, and then the temporary value is assigned to the right one, did we swap the values? And the answer is no. The answer is no. And this is you're gonna have to recall the lecture we went over about referencing variables. Here's the reason why the answer is no. When you call the swap function, the variable first and the variable left refer to the same piece of storage. The storage has the value 6. The variable last and the variable reference right refer to the same piece of storage. They refer to a piece of storage called 3. So now when temp gets created, and that refers to the same piece of storage that left and therefore first are referring to, it's referring to the 6. Last, right, are referring to 3. So if I now say the left reference now refers to whatever right was referring to, left is now referring to the 3. And if I say if I say right refers to whatever temp was referring to, the right reference is referring to the 6. So the left and the right swapped, but the first and the seconds never changed. So it looks like on the eyes, this swap function should work, and we should have the values of first and last should swap. But they're not. We just moved a bunch of references around, but nothing between first and last ever changed. And that's one of the, if you wrote the same function in C and C++, the values would actually, well, the values wouldn't have swapped because they'd be swapping into local variables. So in order to do this, we would want to use the outer variables, the global variables. So this would work if we said, if we passed in left and right and then said the first one refers to what is now considered the right, and the last one is considered the one on the left. The problem here is you have to know the global variables to get this to work. All right, so just trying to point out the difficulties with the values being passed in by reference versus being passed in by, parameters being passed in by reference versus being passed in by value. Okay, suppose we wanted to have a function. This is a very silly function, but it makes an interesting point. Print name nicely. Suppose you have a class object, you have a first name and a last name, and you'd like to print out your first name and the last name with a nice space between them. Okay, that's fine. So you can do that. We can make a function that says print the first name, then a space between it and then the last name. So it makes it format, it makes the printing out of the objects nice. Okay, so as you can imagine, there are probably lots of things like array elements that you would like to print out in nice, neat, even columns with spacing to the left and spacing to the right. So Python supplies a ton of functions for you, so you don't have to write them. So you could do things like print out nice arrays with the columns lined up and totals and big print and all that kind of stuff. So you want to look up all the print functions that Python supplies for you, so you don't have to go and write this yourself. Okay. All right, now parameters, requirements on parameters. So if you have a function that has 2 parameters, a first name and a last name, let's say first and last, and you wanted to print out the first name followed by a space and then the last name, if you call this function and you do not have an argument for each one of the input parameters, you're going to get an error. So if we're requiring 2 parameters, a first name and a last name, and you call the function passing in share with just one name, you're going to get an error because it needs 2 names. If you call it with Elton John, it'll work fine. It'll print out Elton space John. If you called it with Sarah Jessica Parker, it's going to have an error because it needs to know what the first name is and the last name is, and you gave it 3 names and it doesn't know what to do. Okay. Now suppose you wanted to write a function that has a variable number of inputs. Suppose we wanted to write a function, let's say we work for an insurance company and we want to insure the mother and all the kids, but different mothers have different numbers of kids. So we wanted to have a function that will let you type in all the names of your kids. If you have 2 kids, you have 2 kids. If you have 8 kids, you have 8 kids. You can type in the names of the functions, the names of all your kids. And we're not going to say, well, we require that everyone has 3 kids. You know, child 1, child 2, child 3, and then if you give me 2 children's names, we have an error. If you have 4 children, we have an error. So instead of doing that, what we can do is we can say, I want my input parameters to be a variable array. So I'm going to make it kids, and this star means variable in length. So you can supply as many as you want, and then I'm going to go figure out how to read all your inputs by knowing that it's an array, and the first field is array, be kids 0, kids 1, kids 2. And I don't want to read past the end of the array, so I'm going to see how big the array is and then only read to how big it is. So for example, we can write a function that counts how many children you have. So we'd say define, the name of the function is count children, and the input is a variable size array of all your children's names. Then I'm going to say, I'm going to have a variable called number of kids equals, I'm going to call the length function, supplied by Python, you don't have to write it. The length function, you would pass in as an input an array, and it tells you how many elements are in the array. And then I print out you have however many elements are in the array and children. So if you call this function count children with the parameter star kids, and you called it by saying count children, and you said Greg, Peter, Bobby, Marsha, Jan, Cindy, it would return to you, it would print out, you have 6 children. If you gave it 3 children's name, it would say you have 3 children. So you can have a variable list of parameters. So obviously you'll never get an error that says you put in too many parameters or too little parameters, because you're pretty much accepting as many as they want to input. Okay. You can specify the parameters if you know their name. So if you can see the function and you know the parameters' names, you don't have to specify them in order if you know their names. So for example, we can take this print name nicely, which wants a first name and a last name. Well, if you supply it 2 parameters, it assumes the first one is the first name and the second one is the last name. But if you, for some reason, want to give your parameters out of order, and you know the names of the parameters, you know it's first and last, you could call the function by saying print names nicely, last equals DiMaggio, comma, first equals Joe. And this would print out Joe space DiMaggio. Even though you gave the parameters out of order, you gave them names, so it doesn't matter that you gave them out of order. If you don't supply the names, if you didn't have this, then the first name would be DiMaggio and the last name would be Joe. So you could specify parameters by names. Okay. We can have functions that don't do anything. And in a programming language like C and C++ and Java, the way you write a function that doesn't do anything is you would say, you write a function called do nothing, open paren, close paren, you're not giving it any parameters. Void means it's not returning any values to you. And you would say open paren, close paren, and between the open paren and close paren you don't put any code. That means it's a function that does nothing. In Python, because Python doesn't use open paren and close paren, Python uses indentation. If I made a function called define do nothing, and then the very next line I start writing more code, it would cause confusion. Is the next code part of what I wanted in the function and I forgot to indent? Or did I intend for the function to be a function that does nothing and I didn't make a mistake? Well, they don't want to leave that ambiguity out there where a programmer could make a mistake and forgot to indent. So they require that you indent and put in the word pass, which is your way of saying nothing's going on here, just pass over me. You don't do that, it's going to flag you when you go to compile, it's going to say you've made an error, please fix this, and you're going to have to indent and put in the word pass. That's your way of saying, I know this function does nothing. You may be wondering, why would you write a function that does nothing? Well, sometimes you're making products, and in release 1, you're going to have a certain set of functions, and in release 2, you're going to have another set of functions, release 3, you're going to have another set of functions. So you might have one function that calls a function, and right now it doesn't do anything, but in release 2, it's going to do something, but we still want to make a call to it just so we get our syntax correct. So sometimes it's necessary to write functions that don't do anything. And here's the mechanism in Python for doing it. Okay. So what happens when we have a function that doesn't return anything? It just performs a task. So for example, suppose I have a function that prints out the phrase hello world from a function. Doesn't return a result. It's not like the area function. The area function, you give me a radius, I give you an area. This one, you give me nothing, I perform a task, I print something out, and then I return nothing back to you. So, the way, internally, the way functions work is, your program calls a function, the function runs, and when it's done, it goes back to where it left off. Well, where it left off is looking for results. Whether the function returns results or not, it's looking for results. And so what you're doing is, you could, if you don't send back a result, it'll send a result of none, N-O-N-E. You could also say return and have nothing after it. If you say return, here's the value I'm returning to you. Right, so let me see, I'll show you what I mean by the return. When we calculated the area, I calculated the area A, and then I said return A. I said take this value A and give it to the person who called me. So I'm returning a result. But in this case, I'm just performing a task. I'm not saying here's the result, the area equals 3. I'm not saying that. I'm returning nothing. So what will happen by default is we'll return none. You can also say the word return and put nothing after it. That will also return none. So these two are exactly identical. But maybe, you just want to put the word return there so it looks more like a function. But you don't have to do that. Okay. Okay. Now suppose here's something called default parameters. This is popular in just about every language. Java, C++ has this. Suppose I have parameters like a numerator and a denominator, and I want to calculate a percent. What percent is the numerator from the denominator? All right, so I'm going to just divide the numerator divided by the denominator and send the result back, right? So suppose, for example, I say f, a floating point number, equals, I call the function percent, I pass in a 1 and a 2. So I do 1 divided by 2, and the result's going to come back 0.50000. So it's like 50%. 1 is 50% of 2, right? Okay. Now suppose I want to print out 30 as a percentage, or 200 as a percent. Okay, 30 as a percent of what? 30 as a percent of what? So 1 is 50% of 2. 30 is what percent of what? What's the denominator? So what I could do is I could tell people, you don't have to supply me a denominator. You can if you want to, but you don't have to. And so what will happen is, I can say, I require a numerator, but the denominator is optional. You can tell me what the denominator is, but if you don't want to, I'm going to supply 100 for you. I'm going to make the denominator by default equal 100. So what that means is 1 divided by 2 is 0.5000, but 30 is 0.300. 30 as a percentage of what? Well, if you don't tell me, I'm going to make it 100 by default. So I'm saying the denominator is by default 100. This case we supplied the 2, so that 100 wasn't used. In this case we did not supply the denominator, so the denominator became 100. Okay, so required arguments versus non-required arguments. So for example, if you had this function, the numerator is required, the denominator is optional. Suppose I said f equals percent and I supplied nothing, I'm going to get an error. Why? Because I was required to supply a numerator and I didn't. Suppose I said f equals percent. I supplied the denominator, which is optional, but I didn't supply the numerator. So could it take 200 as the numerator and then have the denominator default to 0? No, because I specifically said the denominator is 200, which means I didn't supply the required parameter, which is numerator. Okay, so keyword arguments, a little bit of a recap here. Okay. So I could have a function that says numerators are required, denominators are optional, I'll supply it for you if you don't supply it. And I could say percentage denominator equals 200, numerator equals 100, this would be fine. And I'd be overriding the default in that case. Okay. I could write a function called sum, and I could make it an array of numbers. So you give me a bunch of numbers, I'll add them all up and tell you what the result is. So I will return, I'll do the sum function on an array of numbers. So if I said f equals sum 135, 135 will come in as the array numbers. I will be able to call the sum operation, which is supplied by Python, the sum function. It'll add them all up and it'll tell you the result will be 8. I could say sum 1357, it'll add them all up and it'll be 15. So that's just variable arrays of parameters coming in. Okay. Okay, so now an interesting topic. This is a topic where we're not creating, this is called a lambda function, which is actually, lambda is a Greek letter, so. Whenever something confusing in math or computer science comes out, they just pull a letter out of the Greek alphabet and then they just call it Greek letter. All right, so anyway, so a lambda function is actually a template for a function. So suppose, for example, I needed to write a bunch of functions, and I wanted to do like a multiply by function, right? Okay, so in other words, suppose I wanted to write a function called multiply by 2. So you would give me an input parameter, I would multiply it by 2, and I would return, here's your number multiplied by 2. Suppose I also wanted to have a function multiply by 3. You give me an input value, I multiply it by 3, I give it back to you. So I'd have to write one function called multiply by 2, and then I'd have to write a separate function called multiply by 3, and then I'd have, if I wanted to do multiply by 4, I'd have to do that. And maybe I'm writing a big piece of software and I need tons of functions. Multiply by 2, multiply by 3, multiply by 4, multiply by 5, and this is going to go on forever. So I'm going to be writing a lot of functions. I can write them all at once by doing this. I could say define multiplied by and take in a parameter of n, and I can return, I'm not returning a number, I'm actually returning a function definition. I could say return lambda, a, my input parameter, then colon, a times n. So for example, I could then, all right, so here's what I did. This is not up here, so let's just take this slowly. This up here is not a function, it is a template to generate many functions. So for example, here I'm saying double me is equal to multiply by 2. So what am I doing? Double me is not a number and this is not a function. This is a lambda function. I'm saying multiplied by 2. The 2 comes in as a parameter here and this thing spits out not a result, but a function. So what comes out of here is, you give me an input parameter of a, and I will multiply it by 2. So double me is now a function that I can use to then call as, double me use the multiply by lambda function to generate a function called double me. Double me is now a function that takes in an input parameter and doubles it and returns it. So I can now say x equals double me 3 and it will return a 6. So a lambda function is a template to generate other functions. Effectively, the above code generated this. So if you wanted to, maybe I should have done this first and done this second. If I wanted to have a function called double me, you give me an input value and I multiply it by 2 and give it back to you, the way we would do that is I would write a definition, I'd call it double me, take in an input parameter of a and return a times 2, give that back to you. You give me a number, I'll double it. So suppose I wanted that. Then suppose I wanted another function called triple me and quadruple me. I think we're on the next slide. I could write this over and over and do cut and paste and make a triple me, quadruple me, and so on. But the other thing I could do is I could write a lambda function, define multiplied by, take in a number, and spit out a function. You tell me what you want to multiply it by, and I'll spit out a function that multiplies it by that. So, I'm hoping, okay, good, thank God. All right, so here's the idea. I make a lambda function, define, multiply by n, and I return lambda a n times whatever the number is. Now I come along, I say I need a double me function. Double me equals multiply by 2. I need another function that you give me an input, I'll triple it and give you the result back. I need a quadruple me, and you give me a number, I'll quadruple it and send it back to you. So now I can say multiply by 2 is a function called double me. Multiply by 3 is a function called triple me. Multiply by 4 is a function called quadruple me. So the lambda function supplies a template for how to build functions. Here I'm actually building the functions, and here I'm using the function. So if I say x equals double me and pass in a parameter of 100, x will become 200. If I say triple me and pass in a parameter of 100, y will become 300. Right? So what is double me and triple me? These are functions that I generated using this lambda function. So just once again, a lambda function is a function that can be used. You define a function which then can be used to generate other functions that are all similar to each other. So you don't have to write 1,000 functions, you could just write it once. So this is a lambda function, this is a non-lambda function, non-lambda function, non-lambda function. Okay. All right, so, sorry about that. All right, so like I said, when we start talking about classes, when we start making classes, a class is going to basically be a chunk of storage and a collection of functions that read and write to that storage. But we're not going to use the word functions when they're inside of a class, we're going to use the word methods, but all the stuff we covered today applies. So, and we can even make these